All right, picking up where we left off with simplifying. Let's look at some add subtract problems now. So when we are adding and subtracting, we're really just going to kind of combine like terms. Whoops. We're really just going to combine like terms, but like by like radicals, so to speak. So let me show you what I mean with that. Say we had 6 root 11 plus 9 root 11. Root 11 and root 11, I'm looking at like, let me think of these. When I say root 11, I'm going to say oranges. I have 6 oranges plus 9 oranges. How many oranges do I have? Oh, that's 15 oranges, and oranges are root 11. So my point here is just add the stuff on the outside and treat root 11 like a variable. Do not make that a 22 is my point. So again, maybe I have something like 9 root 3 minus root 3. I have 9 of these minus invisible 1. There's an invisible 1 right here. I have 9 of these minus 1 of these. I have 8 of these, so I have 8 of these root 3s. So adding and subtracting, you're kind of just going to combine like radicals. I'll kind of put that in quotes. But sometimes you don't have like radicals. So with a problem like this, maybe we have 5 root 3 minus root 12. Right now we don't have like radicals. So we kind of have to like make sure we're simplified first. That way we can see if we really have like radicals or not, because it's kind of hiding. This one can't get simplified at all. There's nothing that's perfect that goes into 3, but this 12 we can work with. So let's mess with this 12. What's perfect that goes into 12 is 4. So 4 times 3 is what 12 is. So I can pull out a 2. So then I'd have 5 root 3 minus 2 root 3. And hey, look, now that I've simplified them, I actually do have like radicals. They're both root 3s. So this is 5 of these minus 2 of these. That's 3 of these. So I have 3 root 3s. Let's do another like that. Maybe we have 5 root 8 minus 4 root 72. So on this one, we'll have to simplify both of them actually. So you always want to check if there's any perfect squares that fit. And this one, 4 goes into it. So this is 5 root 4 times 2. And 72 and 9 goes into. That's 9 times 8. So on the 4, a 2 will come out. On the 9, a 3 will come out. So I'll be left with 5 on the outside, and a 2 now came out of that one. The other one, 4 was on the outside, and then a 3 came out. And then the 8 was stuck on the inside. So I've got 10 root 2 minus 12 root 8. Still not like, but I can mess with this 8 a little bit more. Because 8 is 4 times 2. So let's pull another perfect square out. So we've got 10 root 2 minus 24 root 2. And now they match. 10 of these minus 24 of these is negative 14 of these root 2's. So on this video, we looked at simplifying by taking out a perfect square. We did 5 of those. And I showed you a couple ways, whether you do the factor tree or you think about this perfect square list. I'd prefer you think about this list because you should have your multiplication facts down. That's the easier way to do it. I do a problem in this much space or with this big tree and then having to think about the variables separately. Next, we looked at adding and subtracting. When we combine like radicals, you combine the stuff on the outside. The stuff on the inside stays the same. And sometimes we don't start with a like radical. We have to go get it first by simplifying. Once we get to a like radical, then it's pretty straightforward. So next video, part 2, we'll have when we multiply, including distributing and foiling, and then simplifying at the end of everything. And then the last video will be the tricky one, where we deal with simplifying and making sure that we have no improper fractions with radicals, and then dealing with the conjugates to get rid of those. So I will see you next time for that.